Hi there, welcome to the lab. Today we're going to have a look at this Zoyi. This should be a ZT-X model. This also is sold under the label by Aneng. I believe it's called the Aneng Q1. And I got this meter off Valley Express. It looked a little kind of different, so I thought I'd give it a try. I'd just like to ask that if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Questions and comments are always welcome. The feedback is appreciated and helps me to figure out where to focus my activity. Now let's get into the box. An interesting thing, just before we get in there, you notice that this is really meant for rebranding because Zoyi doesn't even put their brand here on the artwork on the box. It just says logo. But it should be a Zoyi ZT-X inside the box. And so in here, there is a temperature probe. We'll have a look at that in a second. A pair of test leads. A pouch. I'm expecting the meters in there. And a user manual. And typical kind of design from Zoyi ZT-X. It's got about, well, let's say 21 pages. And it's all in English. So I guess it'll tell us the specifications and also how to make use of the meter. In the bag, we have the unit, and it is branded, unsurprisingly, as expected, as the ZT-X. And I got this meter because I was a little bit intrigued by the design. So rather than using a rotary dial, they have a bunch of push buttons here to select the various modes. So, I mean, that's something different, so we'll give that a try. And it is 9,999 counts, so that should make for, as long as it has the resolution to support that, that should make for a decent meter. And other than that, I can say that this is a little bit rubbery, so it's not a totally hard plastic there. And it's got the traditional, I guess, Zoyi, they're pretty fond of this particular sticker that says stop testing voltage in current mode. It's a good way to blow your fuses. Now a quick look at the probes just to see what they feel like. So these are sort of the typical, what I would call the typical budget end Zoyi probes. These are pretty small. They're smaller than typical multimeters, and the shrouds come off here to reveal the tips. And we'll just leave those off. And definitely PVC there. And for temperature, rather than just the thermocouple at the end of a wire, they've got this model where you've got sort of a temperature wand, if you will, and the thermocouple is kind of buried somewhere on the inside here near the tip, I think. But it pretty much operates the same way. The thing that is nice, I will say, is that it's got this coiled elastic cord, and so that just, to my mind, makes it just seem a little more durable than the units that just have a little sensor at the end of a fairly flimsy piece of wire. I always figure that's going to get destroyed pretty quickly. Now let's get the batteries in here, and I'll have to take this film off. Yeah. Okay. And it's got this typical Zoyi design where this can come apart, so just be careful about that when you put it back together. And this unit takes a pair of double A's as opposed to triple A's. I guess that's fine. Let's find some batteries. We'll pop those in. 1, 2. And as normal, the unit just turns on its own. It's not uncommon. All right. Now we'll power it up, even though it powered up on its own. We'll power that up. And it's got a very nice display. So this is sort of a new style of display, very bright digits. And so that means you don't have to have a light or a backlight because the display is always illuminated. And so that makes for a very, very nice display, very crisp, very clear. Now this unit doesn't have anything like another light, so there's nothing there. There is some switching here on this, so that changes between AC and DC amps on that power button. It's a little bit weird about how they chose to overload that, but that's fine, that's their choice. And we can see already that there's sort of a multi-line capability here in the AC mode. The frequency is shown here on this little mini secondary display. That's very nice. And then there's a hold function. You can see that there. And if you hold this down for 2 seconds, we get the relative function, and it puts a little delta up in the display. So a lot of functionality there, a lot of basics. This is a very functional meter based on the specs. And so let's put this through its paces and see what it can do. We'll start out with voltage. Now it's started up now in amps, and oddly enough it's beeping. We'll find out more about that later. So press that once for voltage. We can see some noise because it starts out in sort of a millivolt range, if you will. We connect the calibrator, and now that's showing between 0 and 0.1, and of course that's in fractions of a millivolt or hundredths of a millivolt, which would be hundreds of microvolts, if you will. So this is very much in the noise area. If we go up to 0.1 millivolt, we get what amounts to, that's 0.1 millivolts, and that's 99.7 millivolts, so pretty much right on. We'll go up to half a volt, and that's showing pretty much 499.2 millivolts, or it's pretty much right on. Let's take this up to 4 volts. That's pretty much 4 volts. A little bit of variation there around the last digit. We'll take this up to 10 volts now. And of course it's a 9,999 counts, and so that means we lose the first digit there, but otherwise you can see that's pretty much 10 volts with just the last digit of precision varying a little bit. So very good performance in the voltage range. And then we can switch over. Millivolts is kind of interesting because it was operating in millivolts, even though there's a separate millivolt range. And so we can force that to millivolts now. And of course right now it's 0. That's DC, that's AC, that's temperature. So once again that's millivolts. That's 0 millivolts, and so this is down in the microvolt range. We'll just bring that up to 1 millivolt, and so that's showing 0.98 millivolts, so that's pretty good. We'll bring this up to 5 millivolts, 4.97. Once again, that's extremely good. 10, 9.97, whoops, 30, 29.97. Now we'll have a look at DC amps. So the calibrator is producing output. This will be 4 milliamps as soon as we hook it up, and I've plugged the unit in here, and I have switched it into the DC amp mode. So I'll plug that in. That's showing 4,000 microamps, which corresponds to 4 milliamps. So that's really super accurate. We'll take that to 8. Once again, also very good. Now if we go to 12, now that's showing 11.99. So that's 12 milliamps, and that's effectively 12 milliamps. And this can go up to 24 milliamps, 23.98, 24. So pretty much very, very accurate, very good performance here in the milliamp range. Now we can also move this over and just have a look at how this measures when we plug this into the amp range. And so plugged into the amp range, there's no way to specifically tell it to go into a different mode. It's sort of fully auto ranging in that regard. And so it's showing just like before, this is 24 milliamps, it's showing 240 microamps, which is pretty much the same value. So it's reading what we would expect, except it's just doing it as microamps. And so in terms of the ranging, with a higher amp input, perhaps this would range into a higher level. It is supposed to go up to 10 amps. One of the things that I'm not sure if you can notice, you may or may not hear it, but when there's no connection in the amp mode, the meter beeps every couple of seconds. So let's just listen for that. So it does that beep until I plug something in. So when I connect this, it no longer beeps. And I'm not exactly sure why it does that, except to tell us that it's not connected. But I'm not sure why it only does that in the amp range. So interesting, maybe not interesting, but that appears to be a feature. For AC voltage, I have the Bryman here as kind of a reference point to what's appearing on the Zoyi. Their power is off right now, and so we're seeing a little bit of ghost voltage appearing on both of them, so that's totally normal. Now we'll plug it in, turn it on, and pretty much reading the same value exactly between the two. And the frequency measurement here on top of the Zoyi, as we're seeing 60 hertz. The Bryman requires us to push a button here to get the frequency measure, and that's effectively the same thing. So really nice performance here on the Zoyi. Let's just change that one more time. Power it up. Pretty much the exact same reading between the two. So a nice performance in the AC voltage. We'll have a quick look at AC current. I've got a AC fan here, and I'm using the Bryman here as sort of the reference standard, if you will. The Zoyi, as you can see, it's kind of jumping around a little bit, even though there's nothing flowing through yet. The power's off. Let's see what happens when we turn the power on. So we see a high current draw as the motor is spinning up, and now once the motor reaches a steady state, the readings are within a sort of a tenth or so. The readings are pretty close. It's hard to assess exactly. Within 1 or 2 tenths of a milliamp, or in other words, 100 microamps. So very close. Good reading there for the behavior of the AC amp measurement range. Now we'll have a look at resistance. I've already placed it in resistance mode. I'll connect the calibrator. 20 ohms. That's showing 20.3, 0.2 ohms. So fairly good in the ohms rating. Let's take this up to about 100. So 100.2. So 0.34. So off by a couple tenths of an ohm. So that's pretty good. Let's go up to maybe 500. 499.8. That's very nice. 1K. 999.9. That's almost dead on. And we'll go up to 2K. And once again, that's off by maybe 1 or 2 ohms. So a really, very, very, very good performance in the resistance range. Looking at capacitance, I'm using the included probes, and I'll call out the values with the exact measured values in the overlay. So this is 100 picofarads. So that's showing somewhat low. This is 1 nanofarad. So that's a pretty good reading. This is 10 nanofarads. That's also a reasonable reading. 100 nanofarads. That's a reasonable reading. This is 1,000 nanofarads. That's actually a pretty good reading, given that the measured value is fairly off from 1,000. And then this is 10 microfarads. That's a little high, but not too bad. Not too bad at all. Looking at Diode Check, one thing to notice is that Diode Check is mixed into continuity mode, or combined, and that made me hopeful for a moment. Now that's a good reading for diode, and that's also a good reading for the diode, but there's no tone. Now that lights up, and that's a decent reading, another decent reading, another decent reading, another decent, and another one. So that lights up all the diodes, and good readings. There is a tone for continuity because the modes are connected, but there's no short tone for valid diodes that I like to see in a lot of meters, and is present in sort of higher end meters. Now continuity, you can see that brief taps are not doing it. No tone. We see a little bit of response here on the bar graph. It does take a while to respond. I'm just going to switch over to a pair of gold-plated probes to see if that makes a difference. So this is a pair of gold-plated probes, and still not perfect, but much faster. So I can still tap too fast. The graph responds, but I don't get the tone. And normally with continuity, the tone is a lot more useful because you don't want to have to keep looking at the display. So not the best showing for continuity, even with the gold-plated probes. Now we'll have a look at measuring frequency and duty cycle. What's interesting is that you can't just enter frequency measurement by pressing the button that should do it. In fact, you have to press a button to enter a different mode here, and it can't just be DC. Let's try that. You have to essentially get into, I think, DC millivolts. No, you have to get into AC mode first, and then you can press the Hertz or frequency button, and that'll put us into the right mode. So it's a little bit weird to me why they would do that, considering that there's a dedicated button for that. But that is the way it works. The calibrator is set to 0.1 kilohertz, that's 100 hertz. And when we connect it, we see that the meter is kind of jumping around a little bit. Now it's kind of settled down, showing 100 hertz, although it is showing a duty cycle up here in the corner of 76%. The duty cycle by default here is 50%. So I'm not sure what's up with that. Let's boost the frequency here whoops. Let's just go up to 500 hertz. So it's showing 500 hertz. It's not really locking in all that well. And of course the duty cycle is way off here. Let's go up to 1 kilohertz. Yeah, and so at 1 kilohertz it's not even registering anything here. The manual says that this should be able to measure from about 100 hertz all the way up to 5 megahertz, but we can see with the calibrator connected in here, it's not measuring anything close to what the calibrator is producing. The behavior in frequency mode for the Zoyi ZT-X is just not useful at all. And I have checked that the calibrator, what the calibrator is producing is measured correctly with a variety of other meters. For temperature, the unit must have some sort of an internal temperature sensor because it's currently showing 18 degrees Celsius, which is about the temperature here in the lab area. The calibrator can produce the correct output for thermocouples of various types. And so right now I've set it to produce 10 degrees Celsius for a K-type thermocouple, which is what this should be calibrated for. And when I connect that, anything within 2 degrees Celsius is generally considered to be a good reading for these sorts of things. And so 9 Celsius, so that's pretty good. I can take that up to 100 Celsius. Here we see 99 degrees Celsius. We'll take that to 300. 299, another good reading. Take that up even higher. 1,000 degrees Celsius. And so it's showing 998 Celsius. Once again, that's within 2 degrees. So that's a very good reading for the temperature range. And of course, because we have a multi-line display, we see Celsius here, and we also can see a little Fahrenheit display up at the top. For non-contact voltage, I take this plug, and this is the hot line on this edge, and I bring it into proximity to the non-contact sensor. Let's get this into non-contact voltage mode. It shows EF, and we'll bring it in. You can see that at about that distance, it starts to sense. And when it's right on top, we get a very strong reading. Nice performance from the non-contact voltage. Quick look inside the unit. It is meant to be open since it has a couple of fuses in here. So we can see this is the 200 milliamp fuse. This is the 10 amp fuse. The current shunt is over here. Batteries are mounted onto the main circuit board. We've got the buzzer over here. This is an LCD driver. This is some flash memory and EEPROM designed for configuration. You can see the PTC here, so a little bit of protection there. The identity of the main control chip is obscured, like it is with a lot of these units, making the teardowns less and less exciting as time goes on. And this is a relay that's used to probably physically switch some of the inputs over between some of the modes, since the switching is a soft switch. So because these switches are not physical contacts but soft contacts, this is used to switch over in some of the modes where we need to change the physical connection for some of the sensing to be done. And you can hear the unit click as this relay activates for some of the modes to change the switching around. Kind of a novel design here for the current inputs. So rather than having them kind of directly connected to the circuit board, there's a little mini board here, and then these kind of wire in to the main circuit board. A little bit of a different design there. Not clear why they did that. All that probably does is drive up the assembly cost to a degree. And like a lot of meters these days, there's really not a lot of extra circuitry here to see. There should be a non-contact sensor here somewhere, although it doesn't really stand out anywhere. So it's probably might be on the other side or buried up top here. The non-contact performance was okay. And the other side of the board is just populated with the LCD that you can see here. And there'll be all the different soft contact pads for these contacts, for these buttons, that is. This multimeter ended up being a disappointment. I got this multimeter because I was intrigued by the control design. It's a major departure from most other meters that use a dial to specify the mode of operation. This meter uses a set of buttons to select the desired mode. The crisp, reverse illuminated display is really fantastic. Unfortunately, the novel design is insufficient to make up for deficiencies in operation. A few modes don't meet the accuracy spec in their lowest range. The continuity buzzer was a little slow to respond, even when combined with gold-plated probes. The frequency mode was completely unreliable. The controls that seemed to be novel at first were just confusing to work with after a while. I really wanted to like this meter because of its cool, edgy design. Unfortunately, design is not a replacement for fully operational features that, at a minimum, meet published accuracy specifications. If you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Thanks for watching, and until next time.